Hello everyone. This will be just one more review video before the test tomorrow. I'm sorry it took me so long to get it out today, guys. I've been running around trying to get a department iPad to work, and I finally have. I've adapted this from number 29 on page 137 of your textbook. You can find that in the hard copy or in the e-text through Pearson. This is cattle. So an auctioneer sold a herd of cattle, and we're given minimum, median, standard deviation, and IQR. And we're also given that for every cow, we take its weight, we get 40 cents per pound, but we don't just get, but the auctioneer takes $20 a cow. So that should have been a minus sign there. So good thing we checked back through this. Okay. So let's just think about this. This is a scaling. We're multiplying by $0.4 or 40 cents. And it's a shift because we got to subtract $20 off the cost to get what we get paid for each cow. So I've added a few parts to this problem, so maybe we can hit a lot of different things that we've been trying to do examples for lately. I've just kind of made a table here of some things and how they change. Let's see. I guess the important thing to remember is measures of spread, right? Measures of spread do not shift, but they do scale. Measures of location, so things like mean, median, min, max, Q1, Q2, they're sensitive to scaling and shifting. So this little table, if I add sigma down here, no yes, tells us all we need to know about how to alter these things. But first, I'd just like to ask a few questions about what we'd expect about the weight of these cows. If these cows' weights are truly normally distributed, 90% of them should be between what and what pounds. So let me change what I'm sharing for you guys. Over to StatCrunch. All right. So, not given a mean for this problem. Well, we're supposed to assume that these are symmetric, right? Let's call the mean the same as the median. Now, this is just for sake of example. I want to show more how I'm doing it in StatCrunch, right? So if we're assuming perfect normality, perfect symmetry, then the median and the mean would be the same. So I could write median, and that's also the mean. This is only true for very, 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 perfectly symmetric things, but let's for now make that assumption so we can at least finish the example. So we have the median there, or the mean, sorry. Standard deviation is given at 84. And so this is a between idea, right? So I want to capture 90% of the data. So I'm going to put it 0.9 here. I'm using the between version. Hit compute, and it's going to tell me that between sorry, I'm just filling in my answers here. Between 1001.83, yep, and the high end is going to be 1278.17. All right. Let's see. So next question. So I also wanted to know. So no more than 10% of cattle will have weights below blank. So this is that percentile question that I've talked to a couple people about in email, but I just wanted to emphasize it here. If only 10% of cows weigh more than this, then this is equivalent to doing a standard with a 90th percentile, right? 10% above is 90% below. And if we compute, that number would be 1247.65. Okay. One more question. So using my 68, 95, 99.7 rule, tell me, so fill in the blank here. All but blank, but 0.3% of cattle have weights between blah and blah. So let me switch back again. Sorry, everybody. All right. Yeah. So here's what I'm talking about right here. So this 0.3%, right? I noticed that that completes this one, right? So this is 1 SD, 2 SD, 2 SD, 3 SD, right? Okay. So this is 0.3% outside 3 standard deviation. So now we just have to compute 3 standard deviations below and 3 standard deviations above. So I'm going to take our presumed mean, which we had at 1140. Since we're assuming perfect symmetry, the mean and the median are the same. So that was 1140. So I'm going to go 1140 minus 3 times 84. I'm going to do 1140 plus 3 times 84, right? 3 standard deviations. All right. I've got a TI sitting here with me, so just 1140 minus parentheses 3 times 84 close parentheses. This gives me an 888. Do it the other way, 1140 plus 3 times 84, opening and closing parentheses and all that nonsense. That gets me a 1392. So that's what goes here, between 888 and 1392. So the answers we filled in so far in the video are these. All right. So that was my part 1, just to go over normal testing again with that calculator. Okay, so here we're shifting sales prices around. So it says we want to find new minimum, new median, new standard deviation, new IQR. So the idea here, these are measures of location. These are measures of spread. So we already know that these are going to change. They're going to both change. So, and you see again, I'm such a bad person. I used Y bar there. Let's just abbreviate that median, so I'm being very clear. And so I guess I'll just do a little like these ones we shift and scale, and we'll do that for minimum and median. And then the next 2, we'll just have to scale them. We won't have to shift them. Okay, so what would the median for our price be? Well, I just take that 1140 number, 1140, multiply by 0.4 or $0.4, right? 40 cents, and subtract off at 20. And I get that my new median is $436. And what am I trying to say here? I am checking the hell out of these scores in the book so that I can make sure we are perfectly correct. And we are perfectly correct. So the number I get out of that is $436. All right, minimum works the same way. 0.4 times 1140. Ha, 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 ha. Not 1140, but 980. 980. So that's the minimum, right? Minus $20. And just computing that in a trusty calculator, 980 minus a 20. So the minimum price for a cow So since the minimum cow was this weight, the minimum price we're going to get for that cow minus the auctioneer's commission, $372. All right. Now for the ones that we are not, we are only scaling, we are not shifting. So those are easy, right? 0.4, 0.4 multiplied by my standard deviation of 84, I believe. Let's double check. 84. Well, what is that? 0.4 times an 84. Yeah, so we should expect our standard deviation for the money side of things to be 3360. And for the interquartile range side of things, what was our interquartile range? That was 102. So 102 there, pounds. 0.4 times 102, 40.8. There we are, guys. And that's dollars too. Okay, so I hope that helps. I just wanted to do a very explicit example about shifting these. And this is actually why in the last video I suggested OpenStatCrunch, but also bring a calculator. Because you notice StatCrunch, even a calculator that opens on the computer, I just find them to be less efficient than a nice thing I can mash buttons on. So personal preference maybe, but that's my advice. So part 3, which I have titled That Damn Sigma Problem, because yeah, I've turned this into a damn sigma problem. So suppose another normally distributed herd of cows was next at auction. We know that the mean was 1100, and we know that only 10% have weights exceeding 1210. So what's the standard deviation? Well, we're going to have to pop back over to the normal calculator for this. And if you're used to z-tables, this is a great time for a z-table, because I'm actually going to program this as the standard normal curve. So this is computing exactly what you would compute from a z-table. So what do I know? I know that I'm looking at the 90th percentile. Only 10% have weights exceeding, so that corresponds to the 90th percentile. All right, I get my 1.28 right there. So now I just have to solve this formula. My weight, or my mean, so my percentile number there, so that's 1210, minus my mean, 1100, divided by my standard deviation is the same thing as 1.28. So swapping places, the sigma and the z-score there, I got 1210 minus 1100 over 1.28. That is my sigma. And that's how you does that one, guys. Let's see. I'm about to get kicked out of the room I was in, but it occurs to me that I should really recheck this phrasing, because you notice here I said 10% have weights exceeding. Here I have 10% have weights below. So when I warned you that this was backwards, it wasn't backwards, darn it. So let me just fix that real quick. Whoop. Boop, 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 boop. All right. So I'm going to go back to my normal calculator, which you guys are still looking at. Okay, you guys can't even see the screen I'm writing on. That's helpful. So go back to the normal calculator. And let's just try that again. 1140, 84, get me the 10th percentile. So only 10% of cows have weights below this 1032.35, 1032.35. So let me share my thing over here. There it is. So this number should have been 1032.5 there. Not the 90th percentile, but I was actually asking for the 10th percentile there. But Now you know how to calculate the 90th and the 10th percentile for that. So maybe that was good. All right. So again, here's some shifting for measures of location and measures of spread. Um, Here's that darn solve for the standard deviation problem. And here we have some good old-fashioned normal curve calculating proportions and percentiles, and even a nice little empirical rule situation right here. So I hope that was helpful. I know it ran a little bit long. And you guys have a wonderful day and good luck on the test tomorrow.